How do you fix the dying ReLU problem in neural networks? Imagine training a neural network and suddenly noticing that many neurons stop firing, just giving zeros all the time. That's the dying ReLU problem, and it can slow down or even stall your model's learning. ReLU, or rectified linear unit, is a popular activation function because it's simple and efficient. But it has a flaw. If a neuron gets stuck with negative inputs, it outputs zero forever. When that happens, the gradient during backpropagation becomes zero, and the neuron stops learning. This can lead to a network that's less capable of capturing complex patterns. So how do we fix this? One way is to switch to ReLU variants. For example, Leaky ReLU allows a tiny slope, like 0.1, for negative inputs. This means even when inputs are negative, the neuron still produces a small output and keeps learning. Parametric ReLU takes this further by letting the slope for negative inputs be learned during training, making it adaptable. Exponential linear units and scaled exponential linear units are other options. They produce smooth, non-zero outputs for negative inputs, helping neurons stay active longer. Adjusting the learning rate is another trick. If it's too high, weight updates can push neurons into the inactive zone permanently. Lowering the learning rate makes these updates more gradual, reducing the chance of neurons dying. Proper weight initialization also plays a role. Using methods like He initialization or Xavier initialization helps keep neuron activations in a healthy range from the start, avoiding the dead zone early on. Batch normalization is a handy tool too. It normalizes inputs to each layer during training, keeping the data distribution stable and preventing neurons from receiving mostly negative inputs. Regularization techniques like dropout can also help. Dropout randomly turns off neurons during training, encouraging the network not to relying too heavily on any single neuron, which keeps them active and prevents dead ReLUs. Fixing the dying ReLU problem is essential because if many neurons die, the network's ability to learn complex data drops. It can slow down training and reduce overall performance. By using these strategies, developers can build more robust neural networks that stay active and learn effectively. This is especially important in applications like image generation with tools like DALL-E or Midjourney, or language models like ChatGPT, where every neuron counts. When you apply these fixes, your neural network becomes more reliable, capable of learning richer patterns, and ready to handle real-world tasks with confidence.